In this video, we are going to look at multiple choice questions on acids and bases, which is self-check 9 from my reference source. We are going to try to be detailed as we come up with the most appropriate objective from each question. Question 1. Which one of the following substances will dissolve in water to give a solution that would turn red litmus paper blue? Now, when you look at a litmus paper, it's basically an indicator that will always tell us the nature of the solution in which we have placed it in. So, when we place a litmus paper and it turns from red to blue, this will be an indicator that the solution in which we have placed our red litmus paper is actually basic. And basic solutions are well known for being rich in hydroxide ions. So our objective, or the substance, must have hydroxide ions with it once it's dissolved in water. So sodium hydroxide solution will be basically sodium hydroxide aqueous. So the hydroxide ions present in sodium hydroxide will always cause the litmus paper to turn blue. So the best answer here is likely to be B. However, when you look at A, C, and D, these are salts. However, these salts, when we dissolve them in water, they will form neutral solutions. Solutions that are neutral to a litmus paper. Meaning, if we place the red litmus paper in each of these three salts, we are likely to see the red litmus paper remaining red. As such, the best option becomes B, sodium hydroxide. Question 2. Which one of the following oxides is soluble in water? So an oxide is basically a compound that contains two elements in which oxygen is one of them. However, for this question, you need to know the solubility of oxides in water. So simply put, group 1 oxides are soluble in water. However, this is not limited to group 1. Some few other oxides will also be soluble in water, as we shall see in the later slides. So in this case, when you look at the options we have, lithium is in group 1, together with sodium, potassium, and so on. For example, when you have your sodium oxide, sodium oxide can dissolve in water to form sodium hydroxide solution. So this sodium oxide will be soluble in water. Lithium oxide in water will form lithium hydroxide solution. Potassium oxide in water will form potassium hydroxide solution. So we shall see some other oxides which can dissolve in water to form these hydroxides. So basically we shall have group 1 oxides being soluble for simplicity. As such, iron 3 oxide will not dissolve in water, aluminium oxide will not dissolve in water, and copper 2 oxide will also be insoluble in water. As such, our best option here becomes lithium oxide, which is option A. So this is more of a fact. That's why it's hard for you to reason out unless you know which oxides are soluble in water. Question 3. The oxide that dissolves most readily in water is? Now, for this question, we already said that basically group 1 oxides are soluble in water. So our answer is inclining towards A, sodium oxide. However, we shall realize that not only sodium hydroxide can dissolve in water to form sodium hydroxide, even calcium oxide can do the same. So here we form sodium hydroxide solution, which is aqueous. However, even our calcium oxide can also dissolve in water to form calcium hydroxide. So you can take note of this as well. Not only group 1 oxides, but even some other metallic oxides can dissolve in water to form solutions. However, we shall put some emphasis on this word most readily. So this word helps us identify between these two options, sodium oxide and calcium oxide, which one should we choose. So sodium oxide will dissolve more readily in water between these two, and then most readily in water from all these four. So the best answer here becomes A, because sodium oxide dissolves most readily compared to its other counterparts. So if we have other objectives whereby we only have calcium oxide and we don't have a soluble oxide present, then calcium oxide could be also an answer to consider. However, for this case, the most readily soluble oxide will be A, sodium oxide. Question 4. Which one of the following gases dissolves in water to form an acid solution? Basically acidic solution. So when you look at nitrogen, nitrogen will not react with water, probably due to the triple bonds between the atoms. It's generally inert or inactive. So nitrogen will not form any acid solution. However, when you look at ethene, ethene will not also dissolve in water. However, ethene can be induced to react with steam in the presence of a catalyst, phosphoric acid catalyst, and high temperatures and pressures. It can easily form an alcohol, which is ethanol. However, with normal water, we shall say ethene will not dissolve in water too. Then sulfur dioxide can easily dissolve in water to form sulfurous acid. This is the main cause of our acidic rain, sulfurous acid. So our best answer becomes C, because this can easily take place. Carbon monoxide will also not react with water, stroke will not dissolve in water. However, it can also be induced to react with steam to form some products. However, in this case, our steam will not be water, even if steam is water. So we can form our carbon dioxide plus hydrogen gas. This is one of the main reactions we normally use to produce hydrogen gas before we use it in the Haber process. So the best answer becomes C, although from our options B and D could seem correct. But take note, we are dealing with water at room temperature. So the best answer becomes C, sulfur dioxide. Most dioxides dissolve in water to form acidic solutions. Almost oxides of nonmetals tend to form acidic solutions when dissolved in water. Question 5. An acid accidentally spilled on a pupil's clothes is best neutralized by a solution of pH. Now for this question, we need to know what a pH scale is. Basically, it's a scale ranging from 0 to 14 that can guide us on determining which solution is acidic and which one is basic or neutral. So for all pH values below 7, we shall consider them to be acidic or acids, while those above 7 will be considered basic. Now, to neutralize an acid, because we are dealing with an acid accidentally spilling on a cloth. So to neutralize an acid, usually we have to bring in a base. That's why these two are far apart, and in between we have the neutral point. So whenever we have an acid reacting with a base, we know that we form salt and water. And this reaction is given a special name known as neutralization reaction. So strong acids with strong bases tend to neutralize, stroke cancel out the effect of one another. So this neutralization reaction can help us know how to neutralize this acid that could have spilled on a people's clothes. So if acids have pH below 7, that means to neutralize the acid we need to get a pH above 7, which will be basic. So in our answers, the pH of 8 is above 7, and it could be the one to neutralize the acid that had spilled on this pupil's clothes. So the best answer becomes D, because this base or this solution having a pH of 8 can neutralize the acid to form salt and water solution, which is neutral. So the answer becomes D. So this one helps you to know that the pH of a base is always greater than 7, while for the acids will always be below 7. That's why D is our only and correct objective, which is D. Question 6. Which one of the following aqueous solutions will produce hydrogen gas with a magnesium ribbon? That of, so they have given us pH values and they want us to identify which of these can produce hydrogen gas. However, we should be knowing some chemical properties of dilute acids with metals. For example, magnesium can react with hydrochloric acid to form magnesium chloride and hydrogen gas, because magnesium is higher than hydrogen in reactivity series. So this can give us a hint that acids or solutions with a pH value that is less than 7 can easily give hydrogen gas. So in this case, our answer can be 2. pH is equal to 2, or D as the answer, because hydrochloric acid should have a pH below 7, and of our 4 options, D gives us that option. However, someone may be able to tell us that magnesium can slowly react with water, or heated magnesium can react with steam. So you can have our magnesium reacting with steam, heated magnesium with steam, to form our magnesium oxide, which is a white solid, plus hydrogen gas. Someone else can come up with this theory, which is right, and will say our water has a pH value of 7, causing contradictions between B and D. So to some extent, B is also right, but because we are dealing with aqueous solutions, of which steam, I don't know that's aqueous. Yes, it's water, it's a gas, but I don't know that's aqueous. So the best answer becomes D. Magnesium reacting with a solution whose pH is less than 7. Although B can be next to D, but our best answer will be D, which is pH being equal to 2. So let's ignore steam because it's not aqueous, it is gaseous. So the answer is D, pH is equal to 2. Question 7. Most metals react with dilute mineral acids to form, the word is most, meaning metals below hydrogen may not displace the hydrogen from the mineral acids. So what do they form? From our previous question, we have seen that magnesium can react with hydrochloric acid to form a salt and hydrogen gas. This is the same reaction that we use to prepare hydrogen in the lab, but instead of using magnesium, we use zinc granules, and that means our salt becomes zinc chloride. That may be formed. So when you look at metals reacting with mineral acids, we tend to produce a salt plus hydrogen gas. So here the best answer becomes by far B as our only answer, not hydrogen gas only, not the salt of the metal only, not the salt of the metal and water, but the salt of the metal and hydrogen gas. The answer is B. Question 8. Which one of the following is or a property or properties of bases? Soapy feel. Most bases, for example sodium hydroxide, when touched you will feel it's a bit slippery. That means it has a feel of soap, it is soapy. So it's true, all bases will have a soapy feel. Neutralizing, like we had seen, bases tend to neutralize acids or the other way around to form salt and water as the only products. And we said these kinds of reactions have a special name known as neutralization reactions. So it is true, bases will neutralize acids. Solutions of bases will have a pH greater than 7. Yes, from the pH scale, anything having a pH greater than 7 will be considered basic. As such, Roman 1, Roman 2, and Roman 3 are correct. So the best option here becomes D. All of them are true. So some addition concerning oxides. We had basically said oxides of group 1 are soluble in water. However, we have some other metallic oxides which are not in group 1, but they are also soluble in water. Calcium oxide, zinc oxide, barium oxide. They all dissolve in water to form hydroxide solutions. So this hydroxide, we also said, is the basic species that determines a solution being basic. So these solutions will have a pH greater than 7, as we have seen in this question. These ones will be our basic or alkali solutions. While non-metallic oxides like carbon dioxide, sulfur dioxide, nitrogen dioxide will always dissolve in water to form corresponding acids. Carbonic acids from carbon dioxide, sulfurous acid from sulfur dioxide, and nitric acid from nitrogen dioxide. And as you can see, these acids will have a pH less than 7. That was some addition concerning the oxides. In this current situation of the COVID-19 pandemic tsunami, let's try as much as possible to stay safe by trying to follow the SOPs. Please stay home. It's considered safer. Thanks for watching. Let's meet again in the next video. If you haven't watched the MCQs concerning hydrogen, feel free to check them out as well.